Today we're going to look at what it takes to get 3 to 4 dB of gain out of a quarter wave ground mounted vertical, and we're going to talk about the construction, the modeling, and the actual results and the bonuses that come along with it. So make sure you watch to the end, and let's get started right now. I wanted to make a video today about my latest antenna project that I've been working on. Actually, I've been working on this for some time, and the amount of gain that I've seen and the directionality that I have seen when using this setup. So stick to the end and you're going to see some modifications that I made that's different than some may have done. But before I begin, let me give credit to where credit is due. You can check out these guys' web channel too. There's Brian ZL3XDJ. I want to thank Brian for the motivation. Looking at his setup that he has at his QTH is just motivation for me to get going. And then there's Tim, Kilo 5 Oscar Hotel Yankee. He's got a video out there that gives some details on specifics of the setup at his QTH, which is in Texas, I believe, which worked well for mine also. So credit to him also. So let's begin with what I started with. First, we have the quarter wave vertical for 20 meters right here. This is made using a telescopic whip. I think it's 18.4 feet in height. I've been using this for some time. I've used it on 20 meters, 10 meters, and such as that. It goes to a piece of PVC to hold the cable connector for the coax here, and the ground was hooked up to my radials that are in the ground right here. This worked really well for a quarter wave on 20 meters, but given the fact that it was only 16 foot tall, sometimes I would say the transmission doesn't get as far as I would like. So I had planned on using a reflector, adding a reflector onto the back of it, which I did right here. And I had tried that with less than satisfactory results in the past based on just trial and error. But I ran across a video by Tim yesterday, Kilo 5 Oscar Hotel Yankee, and he gave some details on what he did with his setup, and I use those same things for mine, and we'll talk about those in a little bit. But this is the parasitic reflector right here. As you can see, it's just a telescopic whip tied to a mirror mount with 8 quarter wave ground radials for 20 meters. And that's just laid on the ground there. This is just a temporary setup to test the functionality, and it worked really well. We'll talk about how it worked. But I will say it worked really good, but being one who can't leave well enough alone, I'm always looking for an improvement. Because when I was using the telescopic reflector right there along with the element, the radiating element right here, it worked real good. This pole right here was not there at the time. We're going to talk about this in a minute, but this pole was not here. I had taken this down so that it wouldn't interfere with this whip. But anyway, when I got everything tuned right, which again was made easier by the information that Tim posted on his latest YouTube video. When I got it right, in my case, it points to the northeast. So from my QTH, this is pointing right toward Europe, this direction right here, to the northeast US and to Europe. And how did it work? Well, it worked really well. What I ended up with was behind the reflector, which is right there to the southwest of me in the southwest United States and Mexico, I received very little traffic. I heard very little. So as far as front to back, it worked real well. And going forward, at first I thought the antenna wasn't working properly, or I didn't have something tuned right because it was so quiet. And then what I started noticing was that all I was picking up was European stations: Sweden, France, England, Italy, Spain, even picked up the Middle East out in Kuwait. But had real good reception. I could hear them, but I couldn't talk to them because I was only running 100 watts. And very few I could get through to. I got through to a station in Italy with a 5.8 report. Talked to one in somewhere else, I think Spain or France, 5.7, 5.8. So I was getting there, but I couldn't break through the pileups. But anyway, so I knew that when I used my half wave, which is the black pole here, when I used this half wave that was connected to the LDG tuner right here, I could make good contact and break through pileups. So again, not being one that could leave well enough alone, I got to thinking, what could I do to incorporate this half wave right here? It's basically a loaded half wave because the antenna tuner is at the feed point of the antenna, so it's basically like a base loaded antenna. And my ground radials were hooked up to the ground on this right here. Let's see if I can do this one-handed. But anyway, typically my standby. So typically this ground that goes to the ground radials is hooked up to the ground lead of the antenna tuner. So essentially what we have is a base loaded half wave for 20 meters right here. So I got to thinking, well, you know, people run Yagis all the time with load coils and things like that. Why couldn't I use this? So what I did was I took this antenna, the original telescopic whip, and I just laid it on, I disconnected it from the coax and laid it on the ground so that it would have no effect on anything. And then I used this half wave end-loaded vertical for 20 meters. And I call it end-loaded because the antenna tuner has latching relays. So once it's got a tune on it, you can remove power and it doesn't change anything. So again, essentially it's an end-loaded half wave. Once I hooked up this end-loaded half wave, and you did it along with this parasitic reflector, things really got better. The contacts that I was able to make were significantly better. They could hear. I knew that they could hear better when I transmitted over this half wave for DX contacts than they could over the quarter wave that you see that's currently right next to it right here. So half wave, quarter wave, half waves has the better transmission. And we'll look at some, of course I did all this before I did any kind of modeling. And we'll look at some computer models in a minute on what the expected outcome would be of using a half wave for 20 meters along with a parasitic reflector. So it works real good. I mean, just outstanding. So Anyway, we'll go inside and look at some computer models here in a minute and continue on. So see you in a little bit. Let me start this part by adding something that I left out from the previous portion of this video, and that was some specifics on the build. Tim had this in his video, and it was a real help for me here at my QTH. But the driven element on the vertical that I had was set up to be resonant with the best SWR at 14.250 megahertz. So that was where I started. Now the reflector is set up so that it is resonant at a 2% lower frequency. So in my case, with 14.25 as being the driven element, I set up the reflector to be resonant at 13.97 megahertz. And that worked out really good because when I had the driven element set up with the nano VNA on it, and then I set up the reflector, it was obvious that there was interaction between the director and the reflector in a positive way. So that was one thing I didn't add in the previous section. So let's look at the modeling for what we're talking about here with the parasitic reflector. First off, let's look at a quarter wave for 20 meters. This is with no reflector or anything else, just a basic ground mounted quarter wave vertical with a radial field. And we see it has a gain of 1.01 dBi. Front to back is 0. And the elevation of the maximum gain is 27.9 degrees. So that's our baseline right there for the quarter wave vertical at 20 meters. Now let's go to the next one. Once we add a reflector that is set up to be resonant at a 2% lower in frequency, we see that all of a sudden we've got a gain of 4.86 dBi. Now that gain is at an elevation of 25 degrees, so it's dropped down 2 degrees for the maximum gain. And the front to back is now at a negative 8.4. And I can say without question that when I put the reflector, the reflector behind the quarter wave whip that I had set up, it was obvious that the stations that were to the back of the reflector were not coming through. I was not picking them up. I was only picking up stations in Europe. So that worked really good. But as I said previously, with a quarter wave driven element, being ground mounted, living in the suburbs like I do, I was not getting the, if you want to call it, the penetration through the surroundings that I'm in. I could copy the stations overseas, but I couldn't get it through any kind of pileups. And like I said, I knew that with the half wave that had the antenna tuner on it, I was able to break through pileups much easier and able to reach these DX stations in Europe from where I'm at. So let's now look at what it is when there is a half wave driven element. So as a baseline, again, we see that we have 4.86 dBi of gain, front to back is 8.4, and our elevation is at 25 degrees. So now let's look at it when we have a half wave for 20 meters with the same reflector. our gain has decreased just a little bit, maybe 0.2 of a dB. We have 4.69 dBi for our gain, but our front to back has improved. So we've now got a negative 9.38 dB front to back, where previously we had an 8.4. So we gained a dB on our front to back. And look at the elevation. The elevation has gone from 25 degrees down to 20. It's obvious from looking at this one compared to the previous one that the radiation has gone lower to the horizon. So I will confirm that I was able to make better contacts after this. What else can I say about it? The results. There was something interesting when I was watching it. As anybody knows who's been on the radio recently, band conditions are not the best here recently. As a matter of fact, you could say they're pretty bad. But when I was watching the waterfall on the rig that I have, you could tell when band conditions opened up, because you would be sitting there watching a flatline waterfall, and then all of a sudden when the band would open up, you would see signals with S7, S8 of signal strength coming all across the spectrum, all across the band. You would see the band open up. And when the band did open up, all that we were seeing, or all that I was seeing, was European stations. I was pointed to the northeast from my QTH here, which is toward Europe. And I picked up many European stations. That was it. I did not pick up anything from the west of me other than the strongest stations that you hear regularly. So the results were obvious. And so let's look at one other thing. One reason I went with the half-wave vertical on 20 meters was with the antenna tuner, was so that on a quarter wave at 40, I could use the same antenna that I did for a quarter wave on 40 meters. All I had to do is tune it up. So you might ask, what is the results of using a reflector for 20 meters if you're trying to run 40 meters, work 40 meters with the same antenna? And this is what we get. So when you have a quarter wave for 40 meters, that includes the 20 meter reflector, which is a quarter wave at 20 meters behind it. It has almost no effect on the 40 meter quarter wave. As we see, instead of the gain being 1.01, the gain is 0.96, which is very little change. Front to back is basically nothing. And when you look at the elevation angle, 27.8 degrees, that's very similar to the quarter wave for 20 meters, which is 27 degrees. So what this allows me to do by running a half wave for 20 meters with the reflector is, when I want to change bands, all I have to do is set the radio to 40 meters, hit the tune button on the tuner, and it lets me use 40 meters with the same wire. It requires no going outside, no changes, or anything like that. So it works really good. So now let's look at the reverse beacon network, and we can get an idea of what the improvement was by using the 40 meter, the 20 meter half wave, which is the same 40 meter quarter wave antenna, with the reflector. So stand by, let's switch to that. So if we look at these reverse beacon results from yesterday, if we look at the ones with a 10-hour ago timestamp on it, you can see that there were just a handful. And this is when conditions were actually fairly good. You could at least see some activity on 20 meters. So there were just a handful of contacts. But when I went to the half wave for 20 meters and did a reverse beacon test, and this is when conditions had gotten worse. They were not any better. They had actually gotten worse. The number of contacts really went up. Now, could some of this be something else? Possibly. But the results are undeniable that it's an improvement using the half wave for 20 meters that is base loaded to work with the 20-meter reflector. So anyway, what else can I say about this? Once I went to the half wave for 20 meters, and when the band would open up, it actually did open up right shortly after midnight last night. And within a 20-minute period, I was able to reach the Czech Republic, Russia, Bulgaria, Hungary, Italy, Slovenia, Spain, and some others with signal reports of 5.7, 5.8, and that's using the 100 watts only with the half wave and the reflector for 20 meters. So I guess in conclusion, what I would say is that it worked really well. It was better than I expected. I wasn't sure that it would work with the base loaded antenna or how well it would work. Although thinking about it, it should work. I just was not aware of how well. And one thing that I may do, now that I know that it works pointing to the northeast, I may set up some post or something like that so that I can move the reflector around. I can move the reflector around to point in different directions, or I can change the reflector to a director. So that way I should be able to hit the northeast, southeast, northwest, or southwest for my QTH by only moving the either reflector or director, however I have it set up. So that's something that may be coming later. I haven't decided yet exactly what I'll do, but as for now, I like the setup with the 20-meter reflector. Works real good. Again, thanks to Tim, thanks to Brian for the inspiration, motivation, and the details that those guys provided to help me to get this to work. So with that, we'll stop and we'll close this video. Not sure what the next one will be, but it should be before long. So stay tuned. If you haven't subscribed, consider subscribing. You won't miss anything that we post next. It's always going to be something to try to share some knowledge. If you think it helped somebody else, share it with them. Give it a thumbs up if you like it. And until next time, take it easy, and we're out. Bye.